1. The brutal truths, pros, cons, and the GIL. To write effective Python, you must understand where it fails. The Global Interpreter Lock, GIL. Python, specifically CPython, the standard implementation, is not truly concurrent for CPU-bound tasks. The GIL is a mutex that protects access to Python objects, preventing multiple threads from executing Python bytecodes at once. The reality, multi-threading in Python is effectively useless for CPU-heavy tasks. Example: image processing, number crunching. It adds overhead without speedup. The workaround, use multiprocessing, spawns separate processes with their own memory space, or write C extensions that release the GIL. Where threading works, I or O bound tasks, network requests, file I or O. The GIL is released while waiting for I or O, performance versus development speed. Python is slow. It can be 10x 100x slower than C++ or Rust due to dynamic typing and interpretation overhead. The truth, you don't use Python for the heavy lifting. You use it as glue code. The fix, real-world Python, relies on libraries written in C or C++, or Fortran, NumPy, Pandas, PyTorch. If your pure Python loop is slow, you are likely doing it wrong. Vectorize it or move it to a lower-level language. Dependency hell. Python's packaging ecosystem, pip, venv, is fragmented compared to Cargo, Rust, or npm Node. Global site packages are a disaster waiting to happen. Practical rule: never install anything globally. Always use virtual environments, venv, poetry, or UV. 2. Memory management and internals. Understanding how Python handles memory distinguishes a junior dev from a senior dev. Everything is an object. In Python, integers, functions, and classes are all objects on the heap. Implication: a simple integer x equals 1 carries overhead, reference count, type pointer, value. Optimization: Python caches small integers, usually -5 to 256. Checking A is B for these works for larger numbers, it fails. Reference counting and garbage collection, GC. Python primarily uses reference counting. When an object's reference count drops to 0, it is immediately deallocated. Cyclic references: if object A references B and B references A, the ref count never hits 0. The GC module, Python, has a cyclic garbage collector that runs periodically to find these isolated islands of reference loops. Practical tip: in high-performance, long-running apps, explicit GC collect is rarely needed, but GC disable can sometimes improve startup time or bulk processing throughput. Slots for memory optimization. By default, Python classes store attributes in a dict. This is flexible but memory-heavy hash map overhead. The fix: if you are creating millions of instances of a class, use slots. It tells Python to allocate a fixed amount of space for specific attributes, bypassing dict. Python. Class point: slots equals x, y, reduces memory footprint significantly. Definite self, x, y. Self, x equals x, dot self, y equals y. 3. Advanced data structures. Stop using lists for everything. The collections module is the standard library's hidden gem. 1. Collections. Deckway. Use case: queues and stacks. Y. List implies O. N. Time for population: 0. Shifting elements. Deckway provides O. 1. Pops from both ends. 2. Collections. Default dict. Use case: grouping data or counting without checking for key existence. Example: Python. From collections, import default dict. Groups equals default dict. List. For name, grouped in data. Groups grouped. Append, name, no key error. Auto initializes list. 3. Heap queue, priority queue. Use case: keeping a running list of the top K items or Dijkstra's algorithm. Mechanism: maintains a minute heap invariant in a standard list. O. Log n, push, or pop 4. Array, array. Use case: storing purely homogeneous numeric data like integers, compactly. Reality: Usually, if you need this, you should just use NumPy. But array is built in. 4. The iterator protocol and generators. This is the single most important pattern for writing scalable Python. Generators versus lists. Lists load everything into memory. Generators yield one item at a time. Scenario: processing a 10 gigabytes CSV file on a machine with 4 gigabytes RAM. Bad: lines equals f. Dot read lines. Memory error. Good: for line in f. Iterates lazily. The yield keyword. When a function contains yield, it becomes a generator. It saves its state, local variables, instruction pointer, and pauses execution. Practical pattern: pipelines. You can chain generators to build processing pipelines that use constant memory. Python. Def read logs, file path, with open, file path, as f, yield from f. Def parse logs, lines. For line in lines, if error in line, yield line. Split. 1. Strip. Usage: memory efficient regardless of file size. Log lines equals read logs, server, dot log. Errors equals parse logs, log lines. For error and errors, process, error, iter tools. Learn this module. It is written in C and is extremely fast. Islice: slice a generator without consuming it entirely. King chain: combine multiple iterables without concatenating lists, avoids memory copy. Cycle: repeat, infinite iterators for simulations. 5. Functions: scopes, closures, and decorators. Mutable default arguments. The classic trap. Default arguments are evaluated once, when the function is defined, not when it is called. Python. Dangerous. Def appendistal element target equals target. Append element. Return target. Print appendistal 1. 1. Print appendistal 2. 1. 2. The list persists. The fix: use none as the sentinel. Python. Def append2 element target equals none. If target is none, target equals. Closures and scope. LEGB. Python looks for variables in this order: local, enclosing, global, built-in. A closure occurs when a nested function captures variables from its enclosing scope. This is the mechanism behind decorators. Decorators are simply functions that wrap other functions. They are essential for cross-cutting concerns: logging, timing, access control, and caching. Practical example: retry logic. Python. Import time from functools import wraps. Def retry max entry trees equals 3, delay equals 1. Def decorator functicle at wraps func. Preserves metadata name docstring. Def wrapper args corgs for in range max entry trees. Try return func args corgs. Except exception as e time. Sleep delay raise exception f failed after max retrieves retries. Return wrapper return decorator at retry max retrieves equals 5. Def unstable network call dot code dot pass. 6. Object-oriented programming, the practical parts. MRO, method resolution order. Python supports multiple inheritance. It uses the C3 linearization algorithm to determine which method to call. Tip: use class name MRO dot to debug inheritance issues. Super is not just parent class. It delegates to the next class in the MRO. Metaclasses. Classes create objects. Metaclasses create classes. Practical use. Most developers never need to write a metaclass. They are used in frameworks, Django models, ORMs, to intercept class creation and modify attributes automatically. Data classes. Python 3. 7+. Stop writing boilerplate init, repbar, and EQ. Python. From data classes import data class field. At data class, frozen equals true, immutable, class user, ID, int, dot username, str. Roles, list equals field, default factory equals list, mutable default fix. This automatically generates optimized init and comparison methods. Protocols, structural subtyping. Python 3, 8+ introduced typing. Protocol. This brings duck typing into the static type checking world, similar to interfaces in Go or TypeScript. Why, you don't need to inherit from a specific base class. If an object looks like a duck, has the right methods, it passes type checking. 7. Context managers with statement. Any object implementing enter and exit is a context manager. This ensures resources are released, files closed, locks released, even if exceptions occur. Creating your own, the context lib. Context manager decorator converts a generator into a context manager. Python. From context lib, import context manager, import os.contextmanager at contextmanager.def destination. CWD equals os, get CWD, os, chdir, destination, try, yield. Finally, os, chdir, cwd always returns to original dir with chingdir or tmp, do stuff in, or tmp.pass. 8. Concurrency, async I/O versus threading versus multiprocessing. Threading, used for I or O bound tasks, API calls, DB queries. Pros, shared memory, low overhead. Cons, GIL limits CPU performance. Race conditions, multiprocessing, used for CPU bound tasks, video encoding, heavy math. Pros, bypasses GIL, uses all CPU cores. Cons, high memory overhead, copies data. Expensive IPC, inter-process communication. Async I/O, single-threaded concurrency. This is the modern standard for high-performance network services. FastAPI uses this. It uses an event loop. Concept, cooperative multitasking. Code must explicitly await to yield control back to the loop. Blocking code? If you run a slow calculation, CPU bound, or a blocking file read inside an async function, you block the entire loop, the server freezes. Truth, async Python is harder to debug than synchronous Python. Stack traces are messy. Correct? Async pattern, Python. Import async IO, import AIO HTTP. Async def fetch, URL session. Async with session, get, URL, as response. Return await response. Text, async def main, async with AIO HTTP. Client session, as session. Tasks, equals fetch, fi, session, for I in range 100. Run concurrent requests. Responses equals await async else oat. Gather, tasks. 9. Modern Python features. 3. 8 to 3. 12. The walrus operator. Equals. Assigns a value to a variable as part of an expression. Python. Old. Data equals f.read. 1024. While data, process, data. Data equals f.read. 1024. New. While data equals f.read. 1024. Process, data. Pattern matching, match or case, Python 3. 10+. It looks like switch, but it's structural pattern matching, like Scala or Rust. It can deconstruct objects. Python. Command equals quit. Match command, case quit. Case move, x, y, move player, x, y. Case attack target, if ice, sa, live, target. Guards, attack, target. Case, print, unknown command. Type hinting. Python is dynamic, but large codebases require static analysis. Tools, mypy, pywrite. Reality, type hints do not affect runtime behavior unless using Pydantic or FastAPI. They are for developer tooling and CI or CD checks. Generics. Use list.str instead of list.str. Python 3, 9+. 10. Performance optimization techniques. When Python is too slow, don't just guess. Profiling. C profile. Deterministic profiling of C execution. Python-MC profile-S, top-time MyScript. PY spy. Sampling profiler that has low overhead and generates flame graphs. Better for production. Optimization hierarchy. 1. Algorithmic fix, OYN 2 to OIN, beats any micro-optimization. 2. Built-ins, usemap, filter, and comprehensions. They are optimized in C. 3. Vectorization, NumPy or Pandas. 4. JIT, compilation, PyPy, alternative interpreter, or Numba, decorator for math code. Python. From Numba import, JIT, at JIT, NumPython equals true, compiles to machine code. Def Monte Carlopi, N samples. 5. Cython. Write Python code with C types that compiles to C extensions. This concludes Part 1, Core Language and Internals. Part 2 will cover production ecosystem, packaging, poetry or UV, testing, PyTest, linting, rough, web development, ASGI versus WSGI, fast API logic, data science and ML stack, practical NumPy or Pandas truths, deployment, Dockerizing Python correctly, multi-stage builds, security, common pitfalls in Python. Would you like me to proceed with Part 2 now? This is Part 2 of 2. This section focuses on the ecosystem, production engineering, deployment strategies, and architectural best practices required for professional Python development. 11. The modern ecosystem, tooling. The Python tooling landscape has shifted drastically in the last 3 years. If you are still using pip freeze greater than requirements, TXT, and pylint, you are outdated. Package management, the truth about pip. Pip does not resolve dependencies effectively. It installs what it's told, leading to inconsistent environments where it works on my machine but fails in CI. The old way. Requirements. TXT. No lock file, no hash checking, dependency hell. The modern standard, poetry or UV. Poetry handles dependency resolution, locking, poetry. Miniming, poetry. Lock and virtual environments automatically. It ensures that the exact versions of subdependencies are identical across all environments. UV by Astral. Written in Rust, it is an extremely fast drop-in replacement for pip and pipcompile. It is the future of Python packaging. Linting and formatting. Enter rough. Stop using Flake 8, isort, and black separately. Rough, a linter and formatter written in Rust. It is 10 to 100x faster than existing tools. It replaces nearly the entire static analysis stack. The rule, configure your CI or CD to fail if rough check or rough format check fails. 12. Testing like a pro. Unit test. The built-in module is verbose and Java-esque. PyTest is the industry standard. Fixtures. Fixtures are the core of PyTest. They handle setup and teardown better than setup. Methods because they rely on dependency injection. Python. Import PyTest. Defined in conftest. Py usually. At pytest.fixture. Def DB connection. Con equals connect. D. B. Yield. Con. Test runs here. Con. Close. Teardown happens here. Def test user query. D. B connection. D. B connection is automatically passed. Result equals D. B connection. Query. Select from users. Assert len. Result greater than 0. Parameterization. Don't write 10 separate tests for the same function. Use at PyTest. .mark. Parameterize. Python. At PyTest. .mark. Parameterize. Input. expected. .pytest, test, test. Hello world, hello world. Def test title case, input, expected. Assert input, title, equals, equals, expected. Mocking, use unit-test, mock, or pytest mock wrapper. Warning, only mock what you own. Don't mock third-party libraries. Internal logic, mock the interface you built to interact with them. Patching, with patch, module. Function, as mock func, is the safest way to isolate side effects. 13. Web development. WSGI versus ASGI. The architecture change. WSGI, Web Server Gateway Interface, synchronous. One request equals one thread. Examples, Flask, Django, Standard. Bottleneck, if a request waits for a DB query, the thread is blocked. You need workers, Unicorn, to handle concurrency. ASGI, Asynchronous Server Gateway Interface, asynchronous. One thread equals many requests. Examples, Fast API, Django, Async, Starlet. Advantage, handles thousands of concurrent keep-alive connections, WebSockets, long polling, efficiently. Fast API and Pydantic. Fast API has overtaken Flask for microservices because it integrates validation, Pydantic, and documentation, Swagger UI, automatically. Pydantic, data validation. It enforces type hints at runtime. Python. From Pydantic import, base model, email str, validator, class user create, base model, username, str, email str, age, int, add validator, age, .defcheckage, cls, versus, if v18, raise value error, must be 18 plus. Return versus usage. Data equals username, me, email, invalid, age, 10. User create, data, raises validation error immediately. Why this matters? It sanitizes input at the earliest possible point, the API boundary, preventing bad data from polluting your domain logic. 14. Data science and ML, the view versus copy trap. In NumPy and Pandas, understanding memory layout is critical for performance. Views versus copies. View, a new object pointing to the same memory buffer. Fast, copy, allocates new memory. Slow. Python. Import pandas as PD. df equals PD. Data frame. A, 1, 2, 3, B, 4, 5, 6. Case 1. Slicing often creates a view. Subset equals df a greater than 1. Case 2. Setting with copy warning. If you try to modify subset, Pandas doesn't know if you want to modify the original df or just the copy. Subset C equals 10. Warning. The fix, always be explicit. Use .loc for assignment or copy if you intend to create a separate object. Vectorization. Python loops are slow. C loops are fast. Vectorization means pushing the loop into the compiled C layer of NumPy. Bad. Python loop. Python result equals. For x, y, and zip, colb, result. Append, xy. Good. Vectorized. Python. Result equals colb. This utilizes SIMD, single instruction, multiple data, CPU instructions. 15. Deployment and Docker strategies. Alpine Linux versus Debian Slim. There is a common myth that Alpine images are better because they are smaller. Do not use Alpine for Python. The reason, Alpine uses muscle libc. Most Python wheels, precompiled binaries for NumPy, etc., are compiled against glibc, standard Linux. The consequence, pip install on Alpine has to compile everything from source, requiring GCC, build tools, making builds slower and the final image often larger or buggy. The solution, use Python. 3. 11 Slim, Debian-based. It supports many Linux wheels out of the box. Multi-stage builds. To keep production images small, use multi-stage builds. Docker file, stage 1, builder. From Python 3, 11 Slim as builder. WORKDIR or app. Copy requirements. TXT. Install dependencies into a local user folder. Run pip install user no cache dir -dir lina requirements. TXT. Stage 2. Runtime. From Python 3, 11 Slim. WORKDIR or app. Copy only the installed packages from builder. Copy from equals builder or root or local or root or local. Copy. Update path. env path equals or root or local or bin. $path. cmd python main. py. The pyc problem. Python generates bytecode, pycache. In Docker containers, you often want to prevent this to save space or avoid permission issues. env variable. python dont write byte code equals 1. env variable. pythonunbuffered equals 1. Ensures logs flush immediately so you can see them in Docker logs. 16. Security, the silent killers. 1. Pickle is dangerous. The pickle module serializes arbitrary Python objects. The risk: unpickling malicious data can execute arbitrary code. Python. Import pickle. A hacker sends this payload. Class exploit. Object. Def reduce, self. Import, OS. Return, OS. System, rm-rf or. The rule: never unpickle data from an untrusted source, cookies, network, user uploads. Use JSON or MSGPack. 2. SQL injection in ORMs. Using an ORM, Django or SQL Alchemy, usually protects you, but raw queries do not. Vulnerable. Cursor. Execute. F-select from users, where ID equals user input. Secure. Cursor. Execute. Select from users where ID equals %s. User input. 3. Assert statements. Assert statements are removed when Python is run with the SQL optimize flag. Do not use assertions for security logic. Python. badd.assertUser. isadmin. Not authorized. If run with Python-O, this line vanishes and the user gets access. Always use standard if statements and raise exceptions for control flow. 17. Architectural patterns in Python. Dependency injection, DI. Python doesn't need heavy DI frameworks like Java, Spring. You can achieve DI simply by passing objects as arguments. Why? It makes testing easier. You can pass a mock DB connection. Python. Tightly coupled, bad. Class service, definite, self. DB equals database. Hard-coded dependency. Loosely coupled, good. Class service, definite, self. DB self. DB equals DB injected. Composition over inheritance. Python supports multiple inheritance, but it leads to the diamond problem and complex MROs. Prefer composition. Build classes that have functionality rather than are that functionality. Instead of class user, email sender, database saver, use class user, which has self, mailer equals email sender, and self.repo equals database saver. The EAFP principle. Easier to ask for forgiveness than permission. This is a Pythonic idiom. LBYL, look before you leap. Python. If key in myDict, value equals myDict key. else, value equals none. EAFP, Pythonic. Python, try value equals myDict key. Except key error, value equals none. Why? EAFP is generally faster in the happy path, no double lookup, and avoids race conditions. Checking if a file exists before opening it is risky, it might be deleted in between. 18. Essential Libraries Checklist, no fluff. These are the libraries you should reach for first in 2024 plus. 1. Network, HTTPX, async capable, better API than requests. 2. Date or time, Pendulum or Python 3. 9 plus zone info. Standard date time is clunky with time zones. 3. CLI apps, Typer or Click. Argparse is too verbose. 4. Data validation, Pydantic. 5. Environment vars, Python-.env. 6. Progress bars, TQDM. 7. Testing, PyTest. Hypothesis, property-based testing. 19. Final truth, Python's role. Python is rarely the whole solution in a high-scale system. It is the orchestrator. It manages calls to the DB, the cache, Redis, and external APIs. If you need raw speed, you move the hotspot to Rust or Go or C++, but keep the business logic in Python. Development velocity is Python's killer feature. Code written in Python is often shorter, easier to read, and faster to ship than almost any other language. Hardware is cheap. Developer time is expensive. Next steps for you. 1. Audit your current project. Are you using requirements? TXT. Switch to UV or Poetry today. 2. Check your Docker files. Are you using Alpine? Switch to Slim. 3. Profile code. Run PySpy on your running app to see where the actual bottlenecks are before optimizing blindly. Would you like me to elaborate on any specific section, such as configuring a production-ready PyProject YAML or setting up a GitHub Actions pipeline for Python? This is Part 3, the Missing Manual Advanced Patterns, System Integration, and Rust Bindings. This response focuses on high-value, non-obvious practicalities that separate intermediate developers from principal engineers. It covers internals, production observability, integrating high-performance languages, and architectural patterns often skipped in standard tutorials. 1. The descriptor protocol, the magic behind the curtain. You use descriptors every day, at property, at class method, super, but few write them. Understanding descriptors is the key to writing reusable, framework-level code. What is a descriptor? It is any object that defines get, set, or delete. If a class attribute is a descriptor, Python overrides the default attribute access behavior objx to call the descriptor's methods instead. Why use it? To enforce validation, type checking, or lazy loading once in a reusable class, rather than repeating logic in every init or property. Practical example, enforcing types and bounds. Instead of writing getters or setters for every field, write a descriptor. Python, class integer field, def init, self, name, minval equals none, maxval equals none, self, name equals name, self, minval equals minval, self, maxval equals maxval, def get, self, instance, owner. If instance is none, return self. Access from class, not instance. Return instance. Fat. Dotsaus God get. Was biva dot downstein shame. Deck daus get. Self. Dot dien shane tauf. Name. Def set. Self. Instance. Value. If not is instance. Value. Int. Raise type error. F self. Name must be an integer. If self. Minval. Is not none. And value self. Minval. Raise value error. F self. Name too small. Instance. Dict self. Name equals value. Class user. Age equals integer field. Age. Minval equals 0. Maxval equals 120. Level equals integer field. Level. Minval equals 1. Def init self. Age. Level. Self. Dot age equals age. Triggers integer field. triggers integer field, set.self.level equals level. The reality, this is how Django models, SQL Alchemy columns and Pydantic fields work internally. If you are building a library or a plugin system, descriptors are mandatory knowledge. 2. Integrating Rust with PyO3, the performance nuclear option. If optimization in Python, vectorization, Python is not enough, the modern industry standard is Rust. Why PyO3 over C++, Boost or PyBind 11. Memory safety, no seg faults. Rust guarantees safety at compile time. Tooling, Maturin, the build tool, makes publishing mixed Python or Rust wheels to PyPI trivial. Speed, it rivals raw C. Practical workflow. You don't need to rewrite the whole app. Just rewrite the bottleneck function. 1. The Rust code, lib. rs. Rust. Use PyO3. Prelude. PyFunction. fn. Heavy computation. Data. vec f64 greater than. PyResult f64 greater than. Let result equals data. Iter. Map. X. X. Pau de Baliev. 2. 0. Plus X. SQRT. Sum. OK. Result. PyModule. fn. MyRust module. py. Python. m. And PyModule. PyResult. Greater than. m. Add function. Rappy function. Heavy computation. m. Dot. OK. 2. The Python usage. Python. Import MyRust module. This runs at native Rust speed, usually 50x minus 100x faster than pure Python loops. Result equals MyRust module. Heavy computation. 1, 0, 2, 0, 3, 0, 1, 0, 0, 0, 0, 0. Market reality. Tools like Rough, Linter, Pydantic v2, validation, and Polars, data frames, are all rewritten in Rust using this exact pattern. If you want to be a top-tier Python infrastructure engineer, learn basic Rust and PyO3. 3. Advanced observability, structured logging, and tracing. Using print is amateur. Using standard logging is often insufficient for distributed systems. Structured logging, structlog. Parsing text logs with regex is a nightmare. Logs should be machine-readable JSON. Library, structlog. Python. Import structlog, structlog. Configure, processors equals structlog, processors. JSON renderer. Log equals structlog. Get logger. Code. Userid equals 42. Log. Info. User login. Userid equals userid. Status equals success. IP equals 127. 0. 0. 1. Output. Event. User login. Userid. 42. Status. Success. IP 127. 0. 0. 1. Timestamp. This can be directly ingested by Elasticsearch, Datadog, or CloudWatch logs without parsing rules. Distributed tracing. Open telemetry. In a microservices world, example, fast API calling a DB calling Redis. If a request is slow, you need to know where. The tool, OpenTelemetry, OTel. Concept, it injects a traced header into every request. This ID propagates through your entire stack. Implementation, use the auto instrumentation agents. OpenTelemetry instrument Python main. PY, this automatically patches libraries like requests, PsychoPG2, and Flask to emit traces without changing your code. 4. Production database patterns, SQL Alchemy, and Alembic. The database is usually the bottleneck. Python's flexibility makes it easy to shoot yourself in the foot here. The n+1 problem. This is the most common performance killer in ORMs. Scenario. You fetch 100 users, then loop through them to access their profile, a related table. Result: 1 query for users plus 100 queries for profiles equals 101 queries. The fix: select related. Performs a SQL join, fetches everything in one query. Use for foreign key or one-to-one, prefetch related. Performs 2 queries, one for main, one for related, and joins them in Python. Use for many-to-many. Connection pooling, qupool. Creating a DB connection is expensive. TCP handshake, auth. Configuration. Never create a new engine or connection per request. Create one global engine with a pool. Pool recycle, MySQL or MariaDB. Kill idle connections after 8 hours. Set pool recycle equals 3,600, 1 hour. To force SQL Alchemy to reconnect before the DB kills the connection. Alembic migrations. Never modify the DB schema manually. Auto-generate, Alembic revision, auto-generate-m, add column, detects changes in your SQL Alchemy models and writes the SQL script. The trap: always review the generated script. Alembic cannot detect table renames, it sees a delete and a create, which destroys data. You must manually edit the script to use renameable. 5. Asynchronous task queues, celery versus dramatic. You cannot run long tasks, sending email, video processing, generating reports, in a web request. The user will time out. The architecture: 1. Producer, the web app, Fast API or Django, pushes a message to a broker, Redis or RabbitMQ. 2. Broker holds the message. 3. Worker, a separate Python process, pulls the message and executes the function. Celery versus the rest. Celery, the industry standard. Huge, complex, supports everything, cron, canvas, chords. Cons: hard to configure, weird serialization errors, heavy. Dramatic, modern alternative. Reliable message delivery, doesn't acknowledge until task creates. Simpler. Arc, built on async.io and Redis, perfect for high concurrency async jobs. Best practice: the transactional outbox pattern. If your DB transaction commits but Redis fails, the task is lost. Solution: write the task payload to a Postgres table inside the same DB transaction, then have a separate daemon read the table and push to Redis. This guarantees at least once delivery. 6. System-level Python and subprocesses. Automation often requires calling other executables. The subprocess module. Stop using OS system. It is insecure, shell injection and deprecated. Correct usage. Python. Import subprocess. Import schlex. CMD equals grep negative R error or var or log. Schlex. Split handles quotes correctly to prevent injection. Rs equals schlex. Split. CMD. Try. Result equals subprocess. Run. Args. Capture output equals true. Text equals true. Check equals true. Raises called process error on non-zero exit code. Timeout equals 10. Prevents hanging forever. Print. Result. std out. Except subprocess. Timeout expired. Print. Command. Timed out. Except subprocess. Called process error as E. Print. F command failed. E. stderr. Signal handling. Graceful shutdowns. When Docker stops a container, it sends sigterm. Python defaults to killing the process immediately. This creates zombie connections or corrupted files. Python import signal. Import sys. Def graceful handler. Signum frame. Print received sigterm. Cleaning up. Closed DB connections. Flush logs. Finish current job. sys. Exit 0. Signal. 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 Sigterm. Graceful handler. Signal. 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 Sigint. Graceful handler. Handle control. Plus C. 7. Functional programming features. Python is not Haskell, but functional patterns make code safer and more testable. Func tools. LRU cache. Memoization. If you have a pure function, output depends only on input, no side effects, that is expensive, cache edit. Python. From functools, import LRU cache. At LRU cache, max size equals 128. Def compute stats, dataset hash. Expensive calculation. Return result. Functools. Partial. Pre-fill arguments. Useful for callbacks or adapting functions to specific signatures. Python. From functools, import partial. Def power, base, exponent. Return base exponent. Square equals partial. Power, exponent equals 2. Cube equals partial. Power, exponent equals 3. Print. Square. 4. 16. Immutability. Python doesn't enforce immutability, but you should. Variables. Use final type hint, Python 3. 8 plus. Collections. Use tuple instead of list, frozen set instead of set. Classes. At data class, frozen equals true or name tuple. 8. Path handling, pathlib. Stop using strings for file paths. Stop using OSTA, path. Join. Pathlib is object-oriented file system paths. Why it's better, Python. From pathlib, import path. Create path object, works on Windows or Linux automatically. P equals path balachit or USR, or bin. Path navigation with OR operator. Config file equals P or local or config. Ini. Easy reading or writing, if config file.balachit exists. Content equals config file. Read text. Encoding equals UTF-8. Globbing. PyFiles equals list. Path. rglob. Py. Recursive search. It handles forward or backslashes automatically based on the OS 9. Handling big data in pure Python. Sometimes you can't use pandas, memory limits, dependency constraints. mmap, memory mapped files. Allows you to map a file into memory as if it were a byte array. You can seek and read without loading the whole file into RAM. Python. Import mmap with open, massive log files. txt r plus b as f, map the whole file. With mmap f dot felino. 0 as milim. Search efficiently using C-optimized find. idx equals milimner. Find berror if idx equals -1. Militma teak idx. Print mulmain read line. SQLite as a data structure. SQLite is built into Python. It is often faster and more memory efficient than a dictionary or list for millions of records. Strategy. Insert data into an in-memory SQLite DB memory. Index it and query it. It acts as a SQL queryable data frame without the pandas overhead. 10. Security, cryptography, and secrets. Never use random for security, passwords, tokens. It is pseudo-random and predictable, Mersenne Twister. The secrets module. Designed for cryptography. Python. Import secrets. Generate a secure reset token. Token equals secrets. Token URL-safe. 32. Compare digest securely, prevents timing attacks. Standard equals returns faster if the first char creates a mismatch. Leaking info. Secrets. Compare digest. User input hash, stored hash. Hashing passwords. Never roll your own hashing. MD5 and SHA1 are broken. SHA256 is too fast. Vulnerable to GPU brute force. Use bcrypt or argon2. Library, passlib. 11. Code organization, hexagonal architecture, ports and adapters. As applications grow, putting logic in views. PY or models. PY creates a tangled mess. The concept: isolate your domain logic, pure Python, no frameworks, from infrastructure, database, HTTP, APIs. 1. Domain, def process payment, amount, int, policy, policy. Result: this code knows nothing about SQL or HTML. It is purely testable. 2. Ports, interfaces, class payment repository, protocol. Defines how the domain expects to save data. 3. Adapters, infrastructure, class Postgres payment repository. Implements the interface using SQL Alchemy. Benefit: you can swap the database, upgrade the framework, or switch from REST to gRPC without touching the core business logic. 12. Monorepos and tooling. Managing multiple Python repos is painful. Syncing shared libraries. Trend: monorepos, one repo, mini projects. Tools: PantsBuild or Bazel build systems that calculate the dependency graph. If you change Liba, they only run tests for service B that depends on it, not servicec. PDM or Poetry workspaces manage multiple packages in one lock file. 13. The gotchas of Python introspection. Eval. An exec. Eval. Evaluates an expression. Exec. Executes a block of code. Rule: 99. 9% of the time, you do not need these. They are security holes. Alternative: if you need to evaluate math strings, use AST, literal eval, safe, or a dedicated parser library. Monkey patching. Python allows you to change methods at runtime. myClass.method equals new method. Use case: only in tests. Mocking. Production: never. It makes code impossible to debug because the source code no longer matches the running code. 14. Iterator lookahead and peeking. Iterators are consumed once. You can't peek at the next item without consuming it. The solution: iter tools. T creates two independent iterators from one. Python. Import iter tools. Gen equals x for x in range. 10. Gen 1, Gen 2 equals iter tools. T general. You can consume Gen 1 fully, and Gen 2 is still at the start. Warning: this stores data in memory if the iterators diverge significantly. 15. Summary of the senior engineer mindset in Python. 1. Memory. You visualize heap versus stack and reference counts. 2. I or O. You know when to use async, I/O, network, vs threading, disk, vs multiprocessing, CPU. 3. Safety. You trust nothing. You validate with Pydantic, type hint with strict mypy, and audit dependencies. 4. Simplicity. You prefer data classes over complex inheritance hierarchies. 5. Polyglot. You are not afraid to write a Rust extension if Python hits a wall. This completes the comprehensive practical guide to Python. You now have the core internals, Part 1, the ecosystem, Part 2, and the advanced architectures, Part 3.